Okay, so let's say we want to take the gradient of this, where a and b are constant scalars, and u and v are scalar fields. It turns out that this is identical to this. And so in this video, we're going to prove that. So to prove this, I'll start by rewriting the left side of the equation. And so now we're just going to recall the definition of gradient. It's going to be the partial derivative with respect to x of this thing in the I direction, plus the partial derivative with respect to y of this thing in the j direction, plus the partial derivative with respect to z of this thing in the k direction. And so that's basically what it is. Now at this point, it's just basic derivatives. I like saying that, right? But basically, it's going to be, for the first one, if you really think about it, it's just going to be a times partial u with respect to x plus b partial v with respect to x, right? That's really all this is going to be. And we can apply that same idea for the other ones. Oh, and by the way, of course, we should just keep that as the I component. And so that's really what we get. Now, really, we can rewrite this stuff as this. So basically, it's a sum of two vectors, right? If you recall, between here and here, this is the analytic definition of vector addition, right? You're really just taking these two vectors and adding each of their corresponding components together. That would give you what you have above. And so that's really why we can go from here to here. But next, for our first one, we can factor out a. And for the second one, we can factor out b. And so this is really what we get. But really, this is the gradient of u. This is the gradient of v. And so as you can see, we have shown that this is equal to this. And so this completes the proof. As you can see, we have shown exactly what we wanted to show. And so this is basically it for this video.